We're in Algebra 1. I'm using my microphone for my computer, so I'll try to speak loud. Hopefully that'll be okay. Today's date is Wednesday, September 9th, 9/9, 2020. We're on two-step equations, and that objective is to solve those two-step equations. This is kind of the last pre-algebra lesson that we have, and then it's kind of normal algebra from here. So again, if you have this sort of metaphor, if I have a scale over here, how do I figure out how much one of those unknown blocks is? And this is one of those questions, like if you went back in time and you were, I don't know, with the Egyptians, and you actually set up this problem where you had these three identical unknown weights, but you had a bunch of these other known weights, this would be a fun puzzle to do. And I don't know, maybe if you gave it to someone that doesn't understand algebra as much, it could be a pretty fun puzzle. So I know that you guys can probably all see the algebra equivalent of this problem, but how would you describe to like a kindergartner or someone little, how would you solve this problem by making sure that both sides are still the same amount? How many weights would you take off and in what order? Why would that make sense? Does anyone have an idea? Any first steps? You don't have to do the entire problem. I'm just curious on what your thoughts are. How would you approach this problem? We want to start removing weights until we have just one unknown on the left. Yeah, Giorgio, go for it.
Put all the one weights, so like the little small, the yellow ones, together, okay? On the left side to the right side.
Yeah, so you're trying to get rid of these ones on the left. Is that what I'm understanding you? So the problem is if we just move them to the right side, then that will make the sides unbalanced. But we can take them off. I maybe misheard you. Can we take them off both sides? Is that what you're advocating, or do you want to actually move them to the right?
No, I was just thinking move it to the right side, but then I realized that you should just take the same amount off both sides. Okay.
There it is. Yeah. So yeah, and then I just want to make sure that everyone understands the logic here. If we just move all of these weights to the right-hand side, then the scales won't be balanced. But as Giorgio correctly saw, that if we take the same amount from the left and the right off, so there's 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So essentially where we're going to remove, you can cross them off on yours. We're going to cross off those 5. We have taken those 5 pieces off with our fingers, and we can cross off 1, 2, 3, 4, 5. It's kind of that L shape at the top. And now we have 3 unknown blocks that equal to, it's a 3 by 4, so 12 of these 1 blocks. As long as we do the same thing to both sides, then we are allowed to keep the scale balanced. Okay, and then what would we do from here? It's basically the same type of problem that we had yesterday. Yeah, let's give it to Yesenia. Go for it.
So you just like see how many you have of the known like amount, and that's like what's on the side, on like the other side. Like how to explain it? I don't know if I'm explaining it right.
Can you try saying it maybe a different way?
So like you count the known, like the known weight, and that's like the unknown whole weight, and so you can just like divide it by 3.
Okay, yeah. So you count up these ones on the right, and you say, okay, that adds up to 12. These are 3 blocks. So you want to take a third of each side. Is that what I'm hearing? Or divide by 3 on both sides?
Divide by 3.
Okay, yeah. And that's the answer, right? So if I take, and so dividing by 3 works for algebra, but I guess explain it to a kindergartner, it would be a little bit hard because they're like, wait, how do you divide by 3? What does that mean? And you can just say, and I guess taking a third is still kind of hard to explain to a kindergartner, so maybe that's not the best metaphor.
3 lines of 4.
Making 3 groups or something like that.
Oh, yeah, that's a better way of saying it. So we have a group here, a group here, a group here, and we have kind of like single groups of just those question blocks. And then if I take off 2 groups of each side, then you still have the same number of groups on each side. That's a great way of explaining it. Yeah, thank you. So essentially, we are dividing by 3. So we'll get rid of 2 of those groups, get rid of 2 of those groups, and we're left with 1 question mark block on the left-hand side is equal to 1, 2, 3, 4 of those Just 1 kilogram blocks or whatever they are. Cool. Okay, so and then let's of course do this algebraically as well. So this has the direct correlation to saying, well, we have 3 unknowns, so 3x, and then we had plus 5 is equal to, and then if you count up the blocks on the right, we had a 4 by 4 block, which is 16 plus that additional 1, so 17. So 3x plus 5 is equal to 17. And we do the exact same method. And it's important to point out why we don't first divide everything by 3, because it's really hard to put 5 into 3 equal groups. I mean, you can do it and you get some really weird fractions, but it makes more sense to first get rid of the 5. So, and that's what we did. We subtracted 5 from both sides. Essentially, we took away 5 of the 1 blocks. We were left with just those 3 unknowns, the 3x, and then we had 12 on the right. And then Yesenia told us to make, or I guess, divide by 3. And I think it was Ashley that told us 3 groups, right? Or I don't know if I'm putting words in your mouth. Yeah, divide both sides by 3, essentially. Divide by 3, divide by 3, and our x is equal to 4. All right, so again, I think we should review our order of operations. I know that you guys are like, rolling your eyes. We've done this before. We know this so well, Mr. Sandell. Let's just review it though. Who wants to tell me what the letters that go in these boxes are? First one is a P. I'll help you out with that. But what are the rest of them? Order of operation. Yeah, Diego, go for it.
Parenthesis.
Yeah, P for parentheses. Yeah, let's do another one. Let's go Haiti, and then we'll go Zeke after that.
E, exponents.
E for exponents, so something like x squared. Thank you. And then Zeke, you want to do the next 2 if you want?
Multiplication and division, so M and D, and they're on the same one because they have like the equivalent. You just do it from left to right.
Exactly. You don't have to do multiplication first. You just do whichever one is on the left first. And then our final 2, and who's student? I don't know. Okay, Giorgio?
Addition and subtraction.
Addition and subtraction, so add and subtract, again, in the same row. Cool. So remember that when we talk about order of operations, if we go down in terms of order of operations, I can't remember which side was down for us. I think we said down was this way, I don't know. When we go down from parentheses to exponents, that's when we're just trying to simplify. Another way of thinking of this is there's no equal to sign. It's just an expression. If I just have a single expression like 3x plus 5x, I need to simplify that and I need to combine the like terms. There's no equal to sign, it's just an expression, not an equation. But as soon as you see an equal to sign when you're trying to solve for x, so if you're gonna be going on this side, the word over here is solve, usually.
Okay, yeah.
Or find, there you are, Carlos. Then we're gonna be going the other direction. That's our general logic. That's why we decided to get rid of the plus 5, because plus is addition, and that's the first thing that we want to get rid of. We always want to get rid of addition and subtraction, then multiplication and division, et cetera, et cetera. We're going from the bottom to the top in our order of operations. And this is when we do have an equation. So I'll say we do have an equal to sign. And just trying to get our vocabulary built here. Stuff that we want to simplify are usually expressions. So I'm going to write expressions over here. And the thing that we want to solve are equations. We want to solve the equation or solve for x, isolate the variable, right? So this is going to be equations. But remember, an equation is built out of expressions. So sometimes you'll be simplifying an expression on the left, and then after you simplify it, then you'll solve it. So sometimes our process looks like we're going to go down first, and then we're going to swing back up after we finish simplifying one of the sides of the equation. So it's not just one or the other. Sometimes it is both, depending on what you're trying to do. All right. So who thinks that they can fill in the blank over here? Solving for a variable means doing what to all of the operations being done to it? It's very similar to the word that we were talking about yesterday, the inverse operation. Yeah, let's give it to Alden.
This might be wrong, but like undoing
Yeah,
all the operations.
that's it. Yeah, undoing. When we're looking at the variable. So I guess the key thing here is underline the word variable. Look at the variable, assuming that the variable is only on one side. What is being done to that variable? In this case, in our example up here, X, let's pay attention to him or her, I don't know. X is being multiplied by 3, and then it is, we're adding 5 to it. That is the operations that are being done to X. So we need to undo those operations. We need to undo the add to 5. We need to undo multiply by 3. Okay, so then we have just a few examples, and then we have homework. And I think like a third of you have already finished homework, so good job, guys. All right, example 1. We have 2 things that we're going to do. Make sure that you do them in the right order. Although sometimes it doesn't matter what order you do them, and as long as you're keeping to the rules of math. But typically there is one easier way. What should we do? Quiet raised hand. I want to call on someone new too, if I can. Who have I not called on? I haven't called on Braden, Jose, or Carlos. I think those are the only 3.
Can I tell you the answer?
You can tell me how you found the answer, which is even better.
Okay.
Go for it.
-7, adding on both sides.
Okay, adding -7 is the equivalent of subtracting 7. So I'm just going to go ahead and 7 if that's okay.
Yeah.
Okay.
And now divided by 5, both sides.
Okay. Can you tell me what happens? What is our new equation after we subtract 7 from both sides?
It's 40 and 5a
40
equals 5a.
And then you said divide by 5 for the next step?
Yes. The answer is 8.
And the answer is 8. You always box your answer. Cool. Thank you. So give me a fist of 5, guys. In terms of doing 2-step equations, how are we doing? 5 is like, I really, really, really understand how to do these. Go faster, please. 4 is, this is a good review. Thank you. 1 is like, I have no idea what we're doing. So
I have a 5.
4, yeah, I saw the 5. You were the first one. I'll pay attention to you first now. Okay, yeah, so 4s and 5s. Cool. So I think that the speed I'm going is about right. Raise your hand if you need any more time to copy down example 1. No one needs more time. Okay, we're on to our final example, and then we can go over to the homework. Okay, so example 2, we're trying to solve for n. We want to think what is being done to n. First, n is being divided by 4, then n, we're adding 2 to it. So we need to undo those with the reverse operations, right? So what am I doing first? Jose's ready to go again. I'm going to give it to someone else, Jose, but thank you. Yeah, Zeke, go for it.
I was gonna say something, but then subtract 2 from 30, maybe, or subtract 2 from both sides.
Yeah, exactly. Subtract 2 from both sides. Again, just going with reverse PEMDAS. So seeing what addition or subtraction we can get rid of, getting rid of that addition. What do we have after we subtract 2 from both sides, Zeke?
Then you'd have 28 equals n over 4, negative 4, n over negative 4.
Perfect. Yeah, thank you. And our final step, what do we do? Alden?
You times by -4.
Yep.
Multiply.
Multiply or times, yeah, on both sides, -4, -4. Ooh, and that's going to be a little bit harder to do. But I think we will get it. Again, those 4's crossed off. We're left with just n. And then who has, what is 4 times 28? 28, does anyone have that? -4 times 28. Okay, I can help you guys off to the side. So we have, I'll just do 28
I
times
think it's
I got 112.
112. Okay, next time we could raise our hand, but thank you. 112. Yeah, just following here, 8 times 4 is 32. So there's a 2, and there's a 3. 2 times 4 is 8, plus 3 is 11, so 112. Perfect. Box our answer, and we're done. Question, Zeke.
Wouldn't it be negative 112?
Good catch. Yes, and I'm sure Alden was about to say the same thing. I saw her hand just briefly pop up there. Yeah. I mean, you guys probably aren't used to this yet, but I love being corrected. It's my favorite thing because it means that you guys really know what's going on. All right, that is the end of the notes. There's nothing underneath here. Let's just give me another really quick fist of 5 on our objective. Again, our objective is, can you solve 2-step equations? Fist of 5 on our objective today. I'm seeing a 4, 5, 4,
hell 5.
5, 5, 4, 4. Carlos, I saw you already did the homework and you know what you're doing, so probably a 5 or 4. Yep, 5. All right, cool. That's the end of the notes.